Hello everyone, this is Dr. Zach and you are here to continue reviewing for your AP exam. So let's begin. So as you were considering question A on your lesson preview, you knew to think about examining where your function was decreasing, but also perhaps you were looking for an inflection point. Now remember, an inflection point is where the second derivative equals 0 or does not exist, but it has to have a place where your concavity switches. So as we look at our possible choices, R and S are good candidates. Now, for me, it was difficult to see, but I am persuaded to believe that both R and S are good answers. Now, for question B, you're using your second derivative test to determine whether the functions have a relative extrema at x equals 0. So perhaps you found the first derivative and second derivative for each one of your functions to determine whether or not x equals 0 was something other than 0. For this problem, it looks like 1 and 3 were good solutions. So just as a reminder, your first derivative will be used to discuss where functions are increasing or decreasing. If you have a relative maximum, your slope has to switch from positive to negative. When you refer to a slope, make certain that you are very specific, the slope of f, or use f prime of x in your references. A critical number is where your derivative equals 0 or does not exist. Once again, inflection points are where your graph switches its concavity, and those can be found where your second derivative equals 0 or where the second derivative does not exist. For example 1, you're looking for the absolute maximum of your function. In order to find the absolute maximum, you want to find the derivative of the function, which would be -1 over your x cubed plus 3x squared plus 20 multiplied by 3x squared plus 6x. Then set your derivative equal to 0 in order to find your critical numbers. You found some critical numbers at x equals -2 and at x equals 0. However, when you're looking for absolute mins and absolute maxes, you want to make a table of values, and within the table of values, you place your critical numbers as well as your endpoints. Now, this table of values is proof for the College Board graders that you know how to find an absolute min and absolute max, but only put the critical numbers and endpoints in this table. For example 2, let's look at f of x. We know that f has a critical number at x equals 0, and we want to characterize the point 0, f at 0. So let's start by taking the derivative. F prime of x is equal to k cosine x minus e to the x. And we know that when we substitute 0 in, we're going to have a critical point. So f prime at 0 must be equal to 0, which tells us that k times the cosine of 0 must equal e to the 0, which is 1. And believe it or not, that gives us our k value, doesn't it? K equals 1. Does that help us? I'm not sure. Let's see here. Do we have a relative minimum or a relative maximum? In order to find that, maybe you want to find your second derivative. So f double prime of x is going to be equal to, substitute your 1 in for your k, and you're going to have negative sine of x minus e to the x. So what is f double prime of 0? That's going to be equal to -1. And if it's at -1, now remember, that was your second derivative, and your second derivative tells you you were concave down at that particular point. And if you're concave down at a critical number, you must have a relative maximum. Just as a reminder, for optimization problems, write your objective equation. Draw and label your picture. Write your equation based on your objective equation. Write a one variable equation. Take your derivative and use a table of values or the second derivative test to show that you have an absolute min or maximum. For example 3, even though the problem looks complex, the calculus behind it is fairly straightforward. Find the derivative of each one of your equations and then make certain you do that extra step to subtract the difference in the dosages. Okay, you have 4 questions that I want you to try. Turn off the video, give these some good practice time, and then check your answers once you're finished. For question number 1, did you notice that you were given the velocity graph? When your velocity is negative, your particle is moving left. At t equals 2, your particle stopped. However, it continued to move left because your velocity was negative. Once t equals 5, your particle began to move right. For question 2, we're trying to find the location for which the absolute maximum of f can occur. So we're given the derivative of f. So we know that our function is increasing since f prime is positive, decreasing where it's negative, then it's 0 at 2, it's still decreasing where we're negative, and then the function begins to increase. From the first derivative test, we know there's a relative max at 0. A relative max could be an absolute max, but you could also have an absolute max at t equals 4 because the graph of f of x is still increasing. For question number 3, we're trying to find the largest area of a triangle. Now, be careful here. The way this triangle is drawn, we have x as one side of the triangle base, but the other side has a length of 6. So when you write the area for your triangle, you should have 1/2 6 plus x times your height, which is 36 minus x squared. Find your derivative and your critical numbers. Put these values into a table and you will find the largest area for your triangle. Question 4. I chose this one because sometimes doing calculus might not be the fastest way to do the problem. Perhaps you should use the answers that are given in order to come up with the answer in the quickest fashion. So today's lesson follow-up is a worksheet, but do not do every question. I want you to pick and choose the questions that you need to pay attention to. So it's time to really focus in on the topics for the AP exam that you need to practice. Now that's it for today's lesson. You have a great day.